There we go. Okay.
Welcome.
Thank you. And sorry about that. I couldn't seem to get the link to work or be able to unmute myself, but I'm here.
Oh, no worries. We appreciate you being here. So I can give you control, or if you're just here on a speaking capacity, then that is also fine. And I can turn this over to you because we're very excited to hear from you.
Oh, and is it possible to unblur your background so I can see the folks in the room? Is that possible?
Yes, let me see how I make that work. Honestly, I'm not even sure how to do it once I'm in the meeting. Oh, there we go. All right.
Awesome.
So there's just a few of us here today because of the holidays. We've got a few people out, but we are recording this meeting so that we can make sure that everybody who needs to hear this information can hear this.
Okay. All right. Thanks very much. And so I will, let me see, I'm going to try to share my screen here.
Yes. You can't get it.
All right, give me 1 second. Can you all see that?
Yes.
Okay, great. All right. Well, thank you for having me. And I wasn't sure exactly like if you all are sort of kicking off an adaptation process or an impacts assessment, or so I was trying not to assume where you are in your process. So if I share anything that's just not relevant or like you've already been down the road, just let me know. And it can also be really conversational. If you have questions as we're going, feel free to interrupt me and I'm happy to discuss it as we go. Okay, so I was asked to talk about climate impacts and particularly as might be relevant to the Suquamish tribe. And I threw a little bit of adaptation in there at the end in case you all were sort of getting started on an adaptation process. But again, happy to skip that if that's not relevant. I was asked to talk about observed changes in the Northwest and projected changes. And I just want to start by noting that much of the science that's currently available about trends that we've been seeing and what's to come is at a broader scale than the Suquamish usual and accustomed areas or the reservation. And so I'll be sharing a lot of information about what's been observed in Washington, for example, or the Northwest. And even though the numbers might not be exactly the same as what you would see for areas of interest to the Suquamish tribe, the trends will pretty much all be the same. They're all going to be going in the same direction. They're all going to be pretty similar in the impacts that we're observing. So it should all still be relevant and useful, even though the numbers aren't specific to the Suquamish tribe right now. Okay. So starting with sort of the real basics around average annual temperature in Washington, over the last 100+ years, the average annual temperature has increased just shy of 2 degrees Fahrenheit, or about 1.1 degrees Celsius. And if you look at average annual temperature for each of those years over time, you can see that we don't actually live in an average world. We have hotter years and cooler years, and we'll continue to have hotter years and cooler years, but the trend is upward. And at some point in the future, and you can already see us sort of getting there, the coolest years may be hotter than the hottest years of the past. So we'll still have variability, but that trend is going upwards. And again, this is only just shy of 2 degrees Fahrenheit or 1.1 degrees Celsius of warming. Globally, we've seen about 1.1 Celsius getting up to about 1.2 Celsius degrees of warming. That doesn't sound like very much, but a lot of the most challenging impacts that we're already experiencing and will experience are in extreme events within these sort of average changes. And so probably the most striking example that we've all lived through was the June 2021 Pacific Northwest heat dome or heat wave. Can you all hear me okay? Okay. So that heat wave really provided a pretty stark picture of the impacts of even just this small amount of warming, what that can look like in the extremes that we experience, and also the resilience gap that it exposes in our communities. So before global warming of about 1.1 degrees Celsius that we've experienced now, that heat wave would have been about a 1 in 100,000 year event. It would have been virtually impossible without the warming that we've experienced. In today's climate, with that 1.1 Celsius warming, this becomes about a 1 in 1,000 year event. So it's still very uncommon, but it would be about 150 times more likely than without human caused climate change. With another 0.8 degrees Celsius of warming, which would bring us to a total of 2 degrees Celsius, which is the Paris Agreement, a projected heat wave like this would happen as often as once or twice a decade. So this is likely to become the kind of thing that we would see more of in the future, even though it would have been impossible pretty much in the past. So what did this heat wave mean for our region's human and non-human communities? We're still a region with very little air conditioning in people's homes. And so communities throughout Washington opened cooling centers. They encourage folks to use places like libraries, pools, shopping malls to get out of the heat. But still, we had hundreds of people hospitalized and at least 138 people died in Washington alone. And even as people required air conditioning to cool down, that was straining our power supplies, and the heat itself was straining the power system. And so places like Spokane had to have rolling blackouts to manage the high demand and the strain of the heat on the system. So even as we need more power, power becomes less reliable because of the strain on our systems at these times. The heat also exposed the sensitivity of our infrastructure. So we had roads buckling, we had asphalt buckle in several places. We had passenger trains and light rail that had to slow down because the potential for the heat to warp the tracks. So we saw that our infrastructure itself was being challenged by the heat. And then our natural communities, the non-human communities, were also affected. So we had, probably most notably of all this, really significant shellfish die-off and impacts on intertidal communities. And again, part of this was really bad timing, that we had extreme low tides at the same time as the hottest time of the day that this happened. But that's how this works out, right? Sometimes it's just you have multiple things happen at once and you get really unlucky, and that's what happened here. Shellfish out on the outer coast actually fared somewhat better because the low tide happened earlier in the morning than in the Puget Sound. So we had shellfish die-off, we had impacts on intertidal communities. We also had impacts on conifers. So we had hundreds of thousands of acres in Washington of scorched conifers. And again, the dark needles heated up in the sun to higher degrees than the ambient air temperature and were basically burned by the sun or by the heat. Although some good news here, again, we're seeing recovery both in shellfish, and we're seeing recovery, new green growth in a lot of those scorched trees in the following year. And again, it's how often events like this happen that will determine how easily these communities can recover from these kinds of events in the future. So we had that incredibly hot summer. We had a lot of wildfire happened after that. And then we had this record wet fall. So we had this sort of climate whiplash happen. And again, the impacts we experienced, like road closures and flooding, to that, the flooding in that fall demonstrate that our efforts to limit warming and our efforts to adapt to the warming we've already experienced aren't sufficient for what we're seeing at only 1.1 degrees Celsius of global warming. So we aren't meeting the challenge in those two ways, or if we were, we wouldn't be feeling these impacts. So that's just one example of one event and how it kind of rippled throughout our region and our communities. But we've been seeing changes in many different areas of importance to our region, including things like our snowpack, which has been decreasing about 25% since between the mid-20th century and 2006. And this matters not only for winter recreation, for wildlife like wolverine that need deep spring snowpack to breed, but also because our snowpack is our summer water supply for fish, wildlife, and people. And the snow is also important storage for all the precipitation we get in the winter, so it doesn't go right into our streams and cause flooding. We're seeing similarly loss in our glaciers. Most Washington glaciers are in decline. So out your way on the Olympic Mountains, we've seen between 1980 and 2009, about a 34% decline in glacial cover or glacial area in that time. Peak stream flows in the Northwest are moving earlier in response to the changes that we're seeing. So this is due to snowpack melting earlier in the season and snow turning to rain earlier in the season due to warming temperatures. And the result is more water in streams in the winter and spring when we don't need it, and less water in our streams in the summer and early fall when we do need it because it's melting earlier, and the whole kind of hydrograph is shifting earlier. And so this sort of bigger, flashier flooding we're seeing in the spring and winter hits salmon in the more like nesting and juvenile stages, and then the low flows and the warmer stream temperatures in the summer are hitting salmon as they're migrating into our waters. And again, that's contributing, that climate change is contributing to increased flooding, such as the 2021 Nooksack flood, which was 2 to 4 times more likely to occur due to the warming we've already experienced. This increase in flooding is due largely to extreme precipitation events, like you might see in a strong atmospheric river, with an additional boost in runoff that comes from increased snow melt when we have rain on snow events. Wildfires in the Northwest and the Western US have also been increasing in number of wildfires, the size of wildfires, and the severity of wildfires. So in Washington, we had over 1 million acres burned in 2015 and almost 850,000 acres in 2020. And that's compared to a 10-year average of 330,000 acres between 2010 and 2019. And in the West, the area that has been burning at high severity has increased 8-fold since 1985. And that's important severity in particular for the ability of forests to recover after wildfires, for risks of things like landslide when you have stand clearing fires and scorched ground that makes it less able to absorb water. So each of these matters a lot for a region. And of course, the smoke impacts that brings to communities and impacts on human health from that as well that we've been seeing a lot of. Out in the oceans, we're also seeing warming and we're seeing exacerbation of marine heat waves. Hi. Y'all are muted, so I can't hear you. you want me to unmute?
Sorry, I'm
Seems-
taking care of some IT issues. We'll be right back with you.
Okay. Do you want me to pause while you do that? Oh, and I can't hear you. You're muted.
We're almost there. I apologize.
Oh, it's okay. Do I need to go back? Did something get missed?
Do you
No.
guys want me to go? No, okay.
Okay. Do you want me to hold on for a second until you're
Is that volume okay for you guys?
Yeah.
Okay, yeah, no, we're good.
okay?
We should be good to go now.
Okay.
All right, thank you.
Yeah, no problem. All right, so we're also seeing impacts out in the ocean. Climate change is warming the ocean and making marine heat waves hotter. So you all might recall the 2014 to 2016 marine heat wave in the Northeast Pacific, which was called the blob. So the blob ultimately saw sea surface temperatures that were 2 to 3 degrees Celsius above the usual over a very large area off of the Northwest coast, which has strong implications for marine ecosystems and connections to those two, salmon and diverse communities throughout, natural communities in the Northwest. One of the most obvious impacts on marine wildlife was the massive seabird mortality that we saw from that event. Particularly Cassin's auklet got hit really hard, and warm ocean temperatures were the root cause of all 5 massive seabird die-offs since 1993. The warm ocean temperatures off the Washington coast have also been linked to warmer air temperatures over coastal lands of the Northwest. So it's also affecting non-marine temperatures as well. Human-generated carbon dioxide is also increasing ocean acidification in Northwest surface waters. The oceans have been absorbing a huge fraction of the carbon dioxide that we've been emitting through the burning of fossil fuels and changes in land use. And that is increasing the acidity of the ocean. In Washington's marine waters, we've seen an increase of 10 to 40% of acidity since 1800. And atmospheric carbon dioxide in the Puget Sound area is increasing faster on the coast, faster than the global average. And local species, including Dungeness crab, krill, and various ocean creatures that salmon depend on for their health are being, any shelled organism basically is being hit particularly hard, and particularly smaller shelled organisms, juvenile crabs and shelled organisms in particular, when their shells are very thin and small, are particularly sensitive to this. Sea level is rising globally, like the absolute sea level value is rising globally, but it's a little complicated in how that's experienced around the Northwest, because we have quite a lot of land movement. So we have uplift in some areas, we have other areas that are sinking, and those rates really are super local and variable across our region. So close to Suquamish, at the Seattle tide gauge, for example, sea level has increased 8.6 inches. That's what's being observed there. Whereas in other areas like Neah Bay, for example, relative sea level is actually going down because the land is rising faster than global sea level rise. That will change when we have a large earthquake and the land will go back down. But right now, in the Puget Sound area, at least near Seattle, relative sea level is rising, and it's gone up about 8.5 inches. Okay, projected future changes. So one thing to note is that if current emission rates continue, global warming could reach 1.5, and remember we're at about 1.1, bordering on 1.2, but we could reach 1.5 as soon as 2030, and it looks very likely that 1.5 will not be avoided at this point. Current agreements globally have us kind of more in the maybe 3-degree range at this point, which is good news in that we are no longer really thinking that some of these higher end possibilities are really likely to happen at this point. Around, we used to be talking 5 or 6 degrees. That looks a lot less likely with some of the changes we're seeing, and particularly the shifts to renewable energies that are happening very quickly right now. But we're still almost certainly going to hit 1.5. And with current agreements looking somewhere in the 2-3 degree range by the end of the century. Although all of that, none of that is certain yet. All of it depends on what we do. But assuming that we do see 1.5 degrees, that's going to put a significant challenge on Washington's communities, economies, and ecosystems. So, for example, with 1.5, we could see a 67% increase in what we call very hot days, which are days above 90 degrees Fahrenheit, which comes with risks around heat-related illness, warmer streams stressing salmon, and more frequent harmful algal blooms. We could see a 38% decrease in April 1st snowpack, which again is reduced water storage for everything that we need in the summer around fish and wildlife and agriculture, drinking water, hydroelectricity, all of those things, and also losses for winter and summer recreation. We also then expect to see higher winter stream flows, again, because we have very warm snow in our region in terms of snow that happens around the freezing point. So it doesn't take very much warming to turn that snow to rain, which like anyone who wants to go skiing at Suquamish Pass knows, because it's like flip a coin, it could be raining or snowing. So just with a little bit of warming, that snow line goes up, we get more rain, which means more precipitation going directly into our rivers in the winter instead of being stored as snow. So that's more river flooding, costly stormwater management and flood protection, and negative effects again on salmon populations because their eggs can be swept downstream with these stronger stream flows in the winter. And then on the flip side, because we have so much water going into our streams directly as rain in the winter and not being stored as snow, and the snow melting earlier, we could have lower stream flows in the summer, a decrease of 23%. Which would reduce summer hydropower, produce potentially conflicts over water resources, and again, negative effects on salmon who are going upstream at that point. And sea level rise. Sea level rise projections are quite variable because it's very sensitive to how much warming we experience, and it's very sensitive to how ice sheets react to that warming. But on average, we expect about 1.4 feet of sea level rise in Washington with 1.5 degrees of warming. And that means coastal flooding and inundation, damage to coastal infrastructure and communities, and bluff erosion. This is all available in a 2018 or in a climate impacts group special report that I'm happy to share with you as well if you want this information beyond this slide. So that's with 1.5 degrees Celsius warming. And of course, we're currently on the path to perhaps twice as much as that. And we're almost certainly at this point going to see 1.5, perhaps in the 2030s. And of course, the problem is that our human and our natural systems were all built to succeed in a climate that no longer exists. And this is really where the challenge comes in. So from our water systems, drinking water, hydroelectricity, dams, to agriculture, our infrastructure, all of our fishing and recreation, all the things that we do in our region, our livelihoods and cultures, and they're all tied to a climate that did not have this 1.5 degrees Celsius warming. And so I don't need to tell you this, but It's very well recognized at this point that tribal communities are among those who are experiencing these impacts earliest and most severely because of their close ties to the land. And so things like losses or changes in traditional foods, impacts on tribal enterprises and livelihoods, like fishing, timber, tourism, impacts on community health from smoke, from heat, from losses in physical and spiritual well-being, from impacts on natural and cultural resources, loss of reservation lands and cultural sites due to sea level rise. So tribes we know are experiencing this in our region. And I also want to very clearly acknowledge that tribes at the same time have been demonstrating incredible leadership around climate mitigation and adaptation. And so even as they're experiencing this, I really don't see any greater leadership being shown than by tribes around these issues. So I know you all are probably very familiar with what we can do, but I never like to give this talk without being clear that there's still a lot we can do. And there's kind of two complementary ways that we approach how we address climate change. The first is mitigation, and that's reducing greenhouse gas emissions so that we can slow and eventually stop the warming. And the good news is that when we stop emitting greenhouse gas emissions, the warming will stop very quickly. So there used to be talk of a lag, things that were like baked in, but actually recent research suggests when we stop emitting global emissions, it'll stop quickly. The other thing that we can do is adaptation, and that's identifying and preparing for and managing the changes that are occurring that we're already facing, even as we mitigate to reduce greenhouse gas emissions. So everything that we can do to be better prepared for the impacts that we're already seeing is adaptation. And that's where most of the work I do falls. And again, just very briefly, just in case you guys are getting like going on an adaptation process, I thought I'd at least sort of touch on the fact that there's good news if you're starting on this, which is that like you don't have to invent the wheel. There's been so much good work done on adaptation and so much excellent work by tribes on adaptation at this point as well, that there are frameworks to draw from. There are wonderful resources out there to draw from. Very generally speaking, the process looks something like starting with defining the problem, which is basically saying, what are the things that we care about and how is climate change going to affect them? And that's typically known as a vulnerability assessment. So you start by just saying, like, what are the things that we care about? What are the species we care about? What infrastructure or community aspects are we concerned about around health or whatever? And you lay out the things that are important to you. And then you systematically go through and think about how climate might affect those things that you care about. Once you've done that, it sets you up to then identify and assess options for reducing risks to those things. And so that's adaptation planning. You look at the things that are driving the risks and you see where you might be able to intervene. If it's salmon and it's, stream temperatures, are there areas where you could do restoration to reduce risks to those streams that look like they might be at risk? You introduce like log jams or beavers, or there's many different things that one could do to help lower the risk to something like that. And depending, you might have to do some triage, but you just systematically go through and see what you can do. Then you implement those actions, you monitor to see if it's working, and then you kind of evaluate. And this is an ongoing process because things will change, your knowledge will change, the climate will change, opportunities will change. And so this is kind of a living process. There's fabulous resources available to do this. Highly recommend the Tribal Climate Change Guide. This is a project out of University of Oregon that Kathy Lynn runs. They have a regular call on the Tribal Climate Change Network. The Tribal Climate Change Guide has the very latest adaptation funding opportunities, a huge database of existing adaptation plans by tribes, and lots of guidebooks and resources for how to do this kind of work. The tribal climate tool, if you want some of that local information about what kind of changes you might see in areas of concern to the Suquamish tribe, there is information in that tool to give you some of those locally specific numbers. I'll show you that in one sec. BIA branch of Tribal Climate Resilience, they have a local annual call for funding and a lot of resources to support adaptation work. And then AT&I has a ton of excellent resources, including a Tribal Climate Resilience Liaison. There's actually 2 of them, a senior one and a junior one. And they're available as a resource to support tribes in putting grants together for adaptation funding, for doing adaptation work. They're a great resource. I know the tribe sent, I think, 3 folks to the Tribal Climate Camp last year, which is also amazing, and run by AT&I and supported. I wear a hat with the Northwest Climate Adaptation Science Center, so we help support the Tribal Climate Camp. The resilience liaisons are also housed within the Northwest CASC at AT&I, so the Tribal Climate Camp is awesome and a great way to get started on this work. And I was happy to hear that several folks from Suquamish were there. And then their tribal climate conferences are also fantastic around renewable energy and the Climate Leaders Summit. And the last thing I wanted to show you was the Tribal Climate Tool, which we developed. We finished it in 2018, and we worked with tribes throughout the Northwest and the Great Basin to try to provide online for free the kind of data that groups typically have to contract with groups like mine to get. And, it could cost tens of thousands to $100,000 to get these kind of impacts assessments of like, how will stream temperatures change? How will summer temperatures change? How will, all the kinds of things that can help you understand your risk. We worked to solicit sort of custom geographies from tribes over the areas that they care about, and then just provide that information so it's just available. And so the Suquamish tribe provided a couple different geographies, including usual and custom areas, the reservation, and there was one more area of interest. So there's 3 different geographies. And so for each of these, you can go through the tool and pull up things like sea level rise data, stream temperature data, soil moisture, fire risk, vegetation change. There's a bunch of different climate variables that could be useful for adaptation planning that are in the tool. There's no historical or observed information in there. And the only other caveat is that, again, we released this in 2018. So there have been some updates to climate models since then, but almost all of that can be crosswalked. And so this might be useful to you. And it has maps and graphs showing changes that are projected to occur under different emission scenarios and under different timelines. So highly suggest checking that out. And then the last thing I'll say is that the Climate Impacts Group, where I work as a resource, I know Guillaume Auger has worked with the tribe to do some watershed sort of stream impacts modeling for Chico Creek. And the Northwest Climate Adaptation Science Center, again, the Tribal Climate Resilience Liaison with AT&I, we co-host, and there's other resources we have through the Northwest CASC. And then finally, I'll just mention the Northwest Climate Resilience Collaborative, which is another federally funded center that we run through the Climate Impacts Group. Under the Northwest Climate Resilience Collaborative, I co-lead with AT&I the Tribal Coastal Resilience Project. And that is another project that aims to support tribes in their adaptation planning and implementation. And we just are putting in a proposal now that hopefully we'll be able to run a small grants program to support adaptation and provide technical services. So keep an eye out for that.